Hello everyone, welcome to the Daily Lives Project channel. Today we're going to open up volume 3 of the robots course, okay? It's right behind me, over there. And let's get to it. Okie dokie, so we got all our parts that we're going to need, okay, on this. So we start with one of these blue ones. Okay, so yes, put one of those blue ones with one of those orange ones. No, on the other side. Yes. No, not in the middle. Get two there. Yeah, just like that. And then you're gonna need one of these. Okay, just like it says right there. Okie doke, yes, so we're doing it wrong. It's like that. Yes. Okay, and now we gotta mount this onto the motor. It's on the two top ones, just like that. There you go. Okay, that's hard to get in. Yes, it's got to be one person doing it. And now we got to clip this one of these unions onto the wheel. Okay. Yes, but this goes round and round, so you can put it anywhere. Doesn't matter. Okie dokie. For this you need the tool. Got to clip it here and here on the tool. Okay. That's why they have this little tool, you see, so that you can just insert the pieces like that. Okay. And now we need now you need those blue parts. These blue here. Okay, you can insert already the white one. Yes.
Number 4, yeah.
No, number 3. Yeah.
Four.
There you go. Yeah, number 4. Yes. And now you're gonna need this. With the 3 are like that. You're gonna insert
Above.
on number 3
Above this.
these two like that. Wait, like that. Yeah. There you go.
Okay.
Okay. And now you have to put this blue one. Okay. On
Top.
these two like that. Okay, clip them there. Then we're gonna need some.
It's 2 or 3.
3.
They're 3 down.
Yeah.
Okay.
And on this orange one, it's also 3 up. It's not orange, it's red.
3 down.
Yeah. See? Just like that. Okie dokie. Now this you're going to put it beneath the blue one like that right there.
Okay. There it is.
Yes. There you go. Okay, we get in there. And now we have
Wait,
to...
is this going backwards?
Yeah,
Step by
like that.
step.
Okie dokie. So volume number 3. While my daddy's building up here the new robots for volume 3, which we're going to call Babe, because it's supposed to be a little piggy. We're going to see what we have in here. So Today magazine tells us about how the first calculator was invented. Okay, so I'm not going to get a lot into it because it might be too boring for you guys. That's why we have Google to search everything. So as you can see, first calculator. So where we first started on the first volume, you can see that everything is evolving. We have our first encyclopedia. Okay, first encyclopedia. How the first calculator started. How the first robots, autonomous robots also started. actually invented by a neurologist and not by an engineer. So he invented this sort of a turtle robot that used to have sensors, okay, photoelectric sensors that used to see the difference in the light shades and used to know if there was an object in front of it, so it could decide where to go on itself. So at the time it was quite amazing. All used parts of gadgets that they used to have at the time. So yes, so it's already starting to evolve quite a lot at the time. Then we talk about electricity, static electricity. For static electricity, as you know, we have to have electrons that are negatively charged, okay, by nature, and protons that are positively charged. And neutrons don't have any charge. So as we know, positive and negative attract, and negative with negative don't attract, okay? They turn away from one another, just as positive with positive charge. So if you take a balloon, for example, and rub against a piece of wool or your hair or textile, the balloon will have a negatively charged surface. The other textile part will have a positive charge, and by rubbing it, they charge both with different poles, okay, negative, positive.
Yes.
And then when you bring them close together again, they tend to give a little shock. So the balloon actually will stay stuck against the other surface because they charged only on the surface. Then it ends up just losing the charge after a while. If you bring it close and put it away very fast, you might hear some little, it's like friction, but it's like electric shocks, okay? Even if you take a pencil, for example, you can also attract pieces of paper if you rub the pencil against a textile and charge it. So yes, so for attraction, they'll be individually charged, one positive, one negative. We actually have an experience that we'll show you guys just now about it. And how does electricity get to our houses, for example, because we're talking about electrons. So there's always a power supply. In this case, it can be a dam of water, can be wind, solar, it can be even, in this case, you can have like coal burning or even nuclear. And what it does is it will be our supply of energy, okay? And to pass the electrons, you have to have a conductor, okay? So in this case, they use, like, for example, copper wire. So to come from the power supply into a transformer, that will increase the voltage. That will go through the high voltage grid, okay? That's what you see on the streets normally, these high big towers of the grid. That's high voltage tension, okay? Then they will lower it down a bit, okay? And then they'll lower it down again. And by doing that, they use transformers. With a transformer, you can higher up your voltage or lower it, okay? To get into the houses, we have to lower it again from the grid. So that will be, in our case here, it's 220 monophase or 380 volts three-phase, okay? And after that, we can just power up our houses and plug whatever we want to. So that's how the electricity supply gets to our house. Then we have static electricity. Here it actually has experience. So if you rub a balloon against a textile, okay, like a jersey of wool, even against your hair, okay, it will work. You can actually light up a lamp bulb, okay, fluorescent lamp bulb. And we got that experience, and let's show you guys.
Mm-hmm.
Mas não, filma a lâmpada, não a, eu acho que estás a filmar a mim.
lâmpada,
Não, a
não é
lâmpada
eu.
está aqui.
A lâmpada.
Só queres a lâmpada,
Onde é que
não o
estás?
balão.
Onde é que estás?
Estou a filmar a lâmpada na frente. Agora já está aqui.
Não, mano.
Tu queres só a lâmpada?
Sim,
só a
aqui,
lâmpada,
assim.
Ok. Okay,
Okie
go.
dokie, so this is using static electricity to light up a light bulb, okay? Fluorescent light bulb, balloon, and as you can see, the lamp goes on. See, you can either do it just like that or just start it direct, which is better because it goes brighter. And the more you create static, the stronger it goes. See, it's even like, even from a certain distance now. So the more charge I'm getting, and you can actually see the electric shocks from the electrons inside the gas of the tube. So I'm all charged up and it just keeps on going. Even through the air, look at that, just like a lightning, eh? Okie dokie, there you go. So I hope you guys enjoyed that. It wasn't easy to do. And now it talks about our little robot that we're building. That's almost there. And so it talks about center of mass, okay, how to balance a robot using legs and everything else. They compare to an ant, okay, that's got a very well balanced structure and legs. It actually says, do you think a robot with many legs is more stable than a robot with less legs? Of course, we know that the more legs, the more supports, so the better stability. And then it says our robot compares itself to a baby, like compares it to a baby crawling, okay, as well. And yes, I haven't seen how it moves. Looks like it's got a little, I don't know what that's for, looks like a tail. And then we go to our programming. So I'll pre-program it, okay, and we'll see what we'll be doing next on our programming. But first, of course, we're going to check out our robot and see what it does. So actually the programming looks like it's got to do a bit of some cool stuff. So looks like we're going to have a background, make it walk, the figure, and maybe talk. Yes, and talk as well. Okay, cool. That will be interesting. So I'll pre-program it and then quickly explain to you guys so that the video does not stay long. I'm trying to shorten down the videos to make them more interesting. Okie dokie, let's do it. Okie dokie, so let's get to the robot in question. Okay. So we did everything we had to do, and now we can see what it is he's supposed to do. So it's all about balance today. We already got it mounted up, and it's all about center of mass, gravity. Okay. And then we talk about a bit of static electricity. Okay. Just to getting like, it's all talking about conducting electricity through electrons. So I hope you guys are enjoying it, and let's get this guy to move. So as you can see, this is what he's supposed to do. So as you can see, that's just the movement, and he's supposed to do this. So it's a moving, walking robot. Okay, and just goes wherever he wants. Okie dokie. Let's pause that quickly. So, how is he walking this way? Because on one wheel, okay, I'll show you here through the instruction manual. So, on one wheel, we introduced this clip, union clip here, onto this extremity. And on the other leg, on the other wheel, on the other side, we did it onto the opposite direction, 180 degrees, you see. And like that, when this one's moving like this, that one's moving already on the other direction. So we get the walking movement, see? Left, right, right, left. Okay? You can see here, you see opposite direction. On this side, and on that side, but of course facing this side. Okay, so we got here and there. That one was on that little hole there, and this one is on this one. Okay, so 180 degrees, and we get this movement right here. And there you go. Okay, let's stop it. Come this side. Crazy robot. Okay, no, not faster. Oh no. Okay, calm down, robot. Wow, okay. That was chaos. Of course, he's got here, as you can see, rubber pulls at the back, these little rubber stoppers, and in the front is plastic. So the fact that it's rubber at the back is just going to give him that pulling, you know, so that it goes and turns. Quite interesting, actually. See, you'd think that he's programmed to walk in a circle, but he's not. It's just because he's sliding with the front feet. Okay, the front legs he's sliding, and the back ones are giving him grip. He's sliding always to the right. Even if I invert polarity and switch off this. Okay, sorry guys. Okay, not so fast. No, this thing is like crazy. Okay, there you go. It's gonna keep on turning to the right, you see. Because although I'm inverting the polarity, the legs are just doing the same movements, you see. So, if we put on the right polarity, okay, positive with positive, negative with negative, he's going to want to walk forward. If we invert the polarity, he's going to want to walk backwards, but these legs at the back won't let him. So instead of going forward and doing a bigger turn, he's just going to be like doing smaller turns, okay? It's like either you go like that, or you're just in the same spot and you're just going round and around, you see. So let's see. He just doesn't like these little steps here. Okay, now let's invert polarity. If we can, it's not easy. Okay, and let's see what he will do if we reverse it. He's supposed to do a smaller turn. Let's see what happens. Like almost stay in the same spots. Okay. Okie dokie. Oh. So there you go. Right polarity walks further. And if I invert it, it doesn't walk long distance. So it's trying to go backwards, but the back legs don't allow it, you see, because they give him traction. Quite interesting. So just by turning this wheel, okay, like that, hooking it up on just one side of the wheel and that one on the opposite side, we have a walking movement, and the back legs are slightly swerving, very slightly, and just give him the proper traction. Okay. And yes, this is all done. Now programming. I already pre-programmed, okay, to show what else can we do. So we're just getting more and more involved in the programming as well. So what you guys think? It looks like a little piggy, doesn't it? Hey, pig, babe. Babe the pig, look at that. It is quite cool. If we go too fast, he'll go so fast he might just tumble. So that's like the limit, you know. So that's how they test cars and everything else, you know. You can have all in theory, paper, calculations, but then you have to get into the test field and make sure that it works. Actually, I thought it would tumble, but it's actually quite balanced. Oh, quite amazing. Okay. I thought it would tumble because of the speed. What if we put it in reverse? What will it do? So it's just spinning faster around and around, almost in the same spot. Before it was going all around, you see. It's actually quite balanced. So that's it, guys. About the programming. Today they gave us a harder task, okay? And that was a harder task. Let's go here to scratch. Okay. So today, first it's told us to do a background, okay? Choose a background, which you can choose a background right over here on this page right here. You got all these backgrounds. I'm just going with what the book says. Could have chose desert, hall, anything. So you can do actually quite a cool video, like complete video on this program. And then you can actually share it on your own like YouTube channel style on Scratch. Okay, so that's also cool. So if you go look for daily life projects, you'll see these projects on the Scratch channel. Okay, so we chose the background. Okay, just like it says on the magazine on volume 3. Then it asked us to choose a cat, a rooster, and a fox, and that's what we did. Rooster and fox. And how do you choose your animals? You just go here and press, for example, animals right here, and it appears all the animals, the fox and the rooster. They got different actions like all of them do. Even the cat does, see, actually runs or walks. Yeah, how do you see the actions? You just go here and press there, like edit, press the cats, and you'll see here it always gives that. You just erase that new one, and then you can choose outfit 2 or 1. Okay, so then it asked us to configure the position of the 3, and so we did. The cat has one position, the fox has another position, and the rooster has another position. Now you can change this position, and how do you know the coordinates? You just pick up the character, move it, and it shows right there. You see? Just changed. Okie dokie. And if you go like that, okay, it goes resets. After that, it asked us to choose the coordinates where it starts, and then what direction do we want each one of them to go. So we wanted the fox to go in the direction of the rooster, and the cat into the direction of the rooster. The rooster always stays in the hen house. Okay, so we didn't give any direction to the rooster. Then it told us to give an action and a sound. So the story is, when the fox is looking at the rooster, he's thinking like, okay, I'm gonna go catch the rooster. And he'll take action and go to the rooster. When he reaches the rooster is going to make a sound and change its appearance, okay, like to a scared appearance. Once the cat sees the rooster in trouble, he goes to the rooster and tells the fox to get out, and the fox goes back to the initial position, and the rooster says thank you. Okay, so that's the whole idea. You can't change like in the first, if you remember on the previous volumes, you can change direction of the cat so that it's facing towards the rooster, which makes more sense, and that's what we're going to do now. Okay, there you go. And now we gave the cat initial coordinates, wait 8 seconds, slide in direction of the rooster. As soon as the fox touches you, okay, you go meow and say get out fox for 1 second, and once you diffuse the message out, you diffuse this code message to everyone. Okay, and why? Because if you don't have this diffusion of this message, like sharing this message out, which is a code, okay, an action, you can't tell what the rooster has to do afterwards, or the fox, because they have to know once this message which is out goes into the system, they have to react. Okay, so to the fox, initial coordinates, I actually put him, this was in the magazine, laying down, then sitting. And how do you change the appearance? For example, I'll show you. Let's say the cat is like this. Okay, he's just chilling, standing still. And once he has to go into the direction of the rooster, before that, okay, we will go to the appearance button right here. let me get this in English. Sorry. Okay. Right there. Okay. So once before he starts gliding to the rooster, okay, we're going to turn his appearance into running. So go to looks, and we go to switch costume. That's how you do it, okay? So switch costume to, let's see what the costume is again. Let's go to the cat costume. That's it right here. It's even quicker. And number 2 is running. Okay, there you go. That's how you change the costume. So on the fox, we gave him one costume. He waits 1 second. Another costume, waits 1 second. And the third costume is him going to the rooster. Okay, that means glide. You give him a time. How fast do you want him to go? So I wanted him to go like from here and then from here to there. So I said 3.5 seconds to this position, and then another 3.5 seconds to the position of the rooster. Then when he receives the sharing message code that I talked about just now, out, he takes action and he glides back to his initial position, and he stops everything, and the whole system, he doesn't do anything else. That's why it's stop. Okay, other scripts in sprites. The rooster, initial coordinates, switch to costume A, which is this one. Okay, and then forever, which is a control. Okay, now you're going to get these controls. So in forever, you will tell them to, if touching the fox, switch to costume C. Go to the costumes and you can see the different costumes. C, B, A. Okay, so switch to costume C, start sound rooster, wait 2 seconds, switch to costume A, wait 1 second, and he will do this forever until when he receives the signal out message, wait 1 second, and then he thanks the cats. Okay, and that's the end of his actions. The cats will original coordinates, wait 8 seconds so that the fox can do his journey. Okay, he will switch to costume 2, which is running, glide to the rooster, okay, for 2 seconds just to give it like momentum. And wait until once he touches the fox, and now this touch the fox is on the sensing mode. Okay, this is where you get the sensing modes. Once touch it, as soon as he touches a fox, it goes meow. Okay, which you can also record your own sounds if you want. He says get out fox for 1 second, broadcast out. You see, he's going to broadcast the code message out, and then he glides for 4 seconds, okay, slowly to this coordinates. Okay, the rooster, we could give the rooster, like, he could be doing A. Touching the fox, he could actually go to C, and then he could switch to costume, I would say B. I think it would be like funnier. Yeah, I think it would be better. Okay, let's see how it all goes, guys. Okay, 1, 2, 3. There the fox goes. Now remember I said he stops, then glides for another 3.5 seconds. You see, how cool is that, guys? Now right here, the costume, did you see that he could have, because before I went to the rooster B, he used to look. Let's see. Wait 2 seconds. but it didn't switch to costume A for some reason. Let's see why. Okie dokie. So yes, in fact you have to like change next costume, switch costume to the next, you see. So you can see the cat is like gives like a run boost. You can see here. Now the system sometimes will have some glitches. So you see, the rooster gave him 3 actions. The cat he's supposed to stay with the second action working. The cat, you see, like 1. This is number 1, 2, 1. Okay, so if that's 1 and this is 2 and that's 1. Okay, so let's see here. Maybe I have to do that. Let me see. It's quite confusing, so you just have to practice. So let's see now. Okay, there you go. Okay. So he changed position, you see? I think he did. No, now it went back to number 1. There you go. Run. Let's see. I'm gonna give myself a chicken. No, you ain't. Help on the way. Get out of here, fox. And thank you, Daylight Project. Yes, because he works for us, okay? The Daylight Projects channel. Okay, guys. So, hope you enjoyed that. Quite interesting, indeed. And see you all on the next one. Out. And how do you share the video? Well, it's easy, okay? Your project. So you save your project, you go to your folder right there, okay? And you see here shared projects. So you click on the project that was saved, my stuff, you change your title and you press here share, okay? There was a button here that said share, and if you want to go see your studio, so here it's all your projects, shared projects, studio, go on profile, and here you see here's your studios. Very cool, the software. Hope it stays for a long time. Okay everyone, so hope you all enjoy this and see you all on volume number 4. With this, I'm out.